Okay, for number 2 on your homework, it's going to ask you the same types of questions, but you have to draw the Lewis structure. So we have N, nitrogen, oxygen, and chlorine. And to know which one goes in the middle, you look and see which one is the least electronegative. And in this case, that's going to be the nitrogen. So we're going to have nitrogen in the center, and there's going to be a chlorine, and there's going to be an oxygen. And so then we need to figure out how many valence electrons we have. Nitrogen has 5, oxygen has 6, and chlorine has 7. So 12 plus 6 is 18. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18. That does not give us enough. So we need to take off some of those and put them there to make a double bond. I'll go ahead and erase this. And then here is our Lewis structure. And so then what we have to do is we have to look at the center atom and see how many electron dense areas there are around it. So we have 1, 2, 3 electron dense areas, and we have 1 lone pair. Now sometimes we will need to use the lone pair if we're needing to determine the geometry, but right now all we need to know is the hybridization and the bond angle. So the hybridization has to do with this first number. So that is the number of orbitals in our hybridized orbital. So we have an S, and then there's 2 more, so we need to have 2 P's. So sp2 is going to be our hybridization, and then we can go look at our information. Our bond angle is going to be 120. All right, here we have PCl3, so phosphorus, and then 3 chlorines. And phosphorus has 5 valence electrons, and 3 times 7, 21 plus 5 is 26. So we would have 2 here to fill up the phosphorus, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So it fills up exactly. So here we have 1, 2, 3, 4 electron dense areas, and 1 lone pair. Again, that 1 lone pair will matter when they're asking you about the shapes. The hybridization then, if there's 4 orbitals, the first one's going to be an S, then there's going to be 3 P's. When there's sp3 hybridization, the bond angle is 109.5. Okay, in question number 3, you're going to have to draw Lewis structures that have an expanded octet. That means that they're going to have more than 8 valence electrons at times on the central atom. So this is an example of that. So we have iodine, and then we're going to have 5 different fluorines that go on here. Okay, so iodine has 7 valence electrons, and each fluorine also has 7 valence electrons. So we're going to end up with 42 valence electrons. So we have 2, 4, 6, 8, 10. So we need 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. So to fill them all evenly with 5 bonds here only takes 40, so there's 2 left. So we're going to put those 2 on the middle because we know iodine can have an expanded octet. And so here's our Lewis structure. So around the central atom, we have 1, 2, 3, 4, 5, 6 electron dense areas with 1 lone pair. So our hybridization is going to be S. There's only ever 1 S. P can have 3, so that's 4. So we need to have D2. sp3d2 is our hybridization. Okay, so now in our resources we see that if we have sp3d2, hybridization, there are two options for bond angle, and those are 90 and 180. So we will put in our options, which are 90 space 180. Basically, on all these problems, the main thing that you're going to want to do is draw the Lewis structure. The main thing you're going to want to focus on these problems is drawing the Lewis structure correctly, and I will be available to help you if you have questions about how to do that. One thing I did want to remind you is if you have something like this, NH4+, that means that you have to take away an electron because of the positive charge. So like when you have
ammonium,
nitrogen has 5 valence electrons, there would be 4 times 1 from the hydrogens, and then this plus means we take away an electron. So we would have 9 minus 1, and we would end up with 8. And as you can see here, we have 2, 4, 6, 8 electrons represented. So this is how you would draw
ammonium.
But I just wanted to remind you about that. And then if you had something like NO2 minus, that means you get to add an electron when you're counting up the total number of valence electrons.